In this example, we are going to determine the inverse of matrix A multiplied by its transposed matrix. Here, the matrix A is a 2 by 3 matrix because it has 2 rows and 3 columns. First, we are going to find the transpose of the matrix A. The transpose of the matrix A is going to be a 3 by 2 matrix where all the columns of the matrix A become rows in the transposed matrix. The next step is to multiply A by the transpose of A. A quick reminder, we can multiply two matrices if the number of the columns in the first matrix is equal to the number of the rows in the second matrix. And the resulting matrix will have the same number of the rows as the first matrix and the same number of the columns as the second matrix. Now, since A is a 2 by 3 and the transpose of A is 3 by 2 matrix, then we are able to multiply them and their product will be a 2 by 2 matrix. For the multiplication, we go across the rows of the first matrix and down the columns of the second matrix. So for the first row, first column, we are going to have 1 times 1 plus 0 times 0 plus minus 1 times minus 1. And we perform the same procedure for the other tier. To find the inverse of this 2 by 2 matrix, we need to find its adjoint, also called adjugate matrix, and then divide that by its determinant. As you can see here, the adjoint of a 2 by 2 matrix is when we switch the main diagonal elements and change the sign of the opposite diagonal entries. So by applying this adjoint rule, we will get this matrix. To find the determinant of this 2 by 2 matrix, we multiply main diagonal elements 2 by 5 and then subtract them from multiplying opposite diagonals 2 by 2, which it results 6. And finally, the inverse of the matrix will be its adjoint matrix divided by its determinant. I will be making more videos on this topic, which I will put the links under the video description.